it's not. Are you guys alive? Hello? No.
August 16th.
How many of you guys are like, I'm done for this? I'm done for this week. That's great. I'm ready for this week to be done.
Ready for this year to be done.
I'm ready for the next 10
Ready
years
for
to
my
be
life to
done.
be
Whoa. Got more than I asked for. All right, so you guys are grading? Has anybody? Sorry, anyone in the video, pause it because we went fast. They already started grading before we started recording. Is anybody still grading this portion? 1, 2, 3. Toby will catch up. Go. All right. Number 38. Matches letter D. Number 28, if you didn't already notice, was 15. Number 40 matches A. I'll give you a little more time on 58 and 76. 76, if you did not think factoring. Oh, here's all the one side, you gotta factor. 58 was a plug-in show? Oh, no way. Okay, questions on evens or odds, going once. Okay. Are you sure? We're good. See a couple bucks to looks. Number 76, it was the, what property, guys, lets you ignore the LNs? The 101 property lets you ignore the LNs. Mathematically speaking, what was the only way to go right here? The only way.
Factor.
But you can't factor until you get it all.
One side.
You gotta get one side equal to 0. So for just a couple of you still struggle with, I should pull out an X. No, you cannot factor until you have one side equal to 0. Just common mistake on there. All right, no questions. 81? Okay, cool. Anything else besides 81? All right, as I get ready to look at number 81, oops, I have way too many things open because I'm trying to go fast today. You guys, go ahead and get your composition books ready to go. Section 3.3. Oh, I almost went to 4. Section 3.3. If you guys need the minimum day schedule, it is on the back board. You can peek at it real fast. Computer doesn't like me multitasking. Oh, it really doesn't like me multitasking. Yes. Yes. Okay. Section. Hey. Okay. As you guys get your composition books, if you don't need number 81, you can start on the next section of notes. There we go. I'm going to freeze the screen for just a second while I actually scroll to number 81 for us to look at. Why do you think I left the change of base blank? How are we going to fill that in? And if you haven't figured out my color coding, well, I guess if you have, why is it green? Blue is new, red is practice, green is review. What did we talk about in section 3.2? What formulas?
Y log AX.
Yeah. We did talk about log base A of x and how it can transform to a to the power of y equals. Good. Change the base formula is the one I was referring to though. So go ahead and if you need to, go back and peek really quickly in section 3.2 notes and fill in the change of base formula. There's actually, what, 3 different variations? Well, technically infinitely many different variations, but go grab that formula for us to use in the discovery problem below. All right, I have found number 81. Human memory. Wow, we could probably all use help in that area. Alright guys, if you guys are ready, pause on those notes for 2 seconds. I want you to think through, either you're stuck and you're paying super close attention, or you've got it and you're about ready to describe how to solve. Human memory problem. Model. Whatever. Students in math class took an exam and then took a retest monthly with an equivalent exam. The average scores for the class are given by the human memory model. Interesting, they actually modeled this stuff, huh? F of t is equal to 80 minus 17 log, common log, of t plus 1 between 0 and 12. So they took it for a year, right? Monthly, 0 to 12, 12 months. Where t is the time in months. Use a graphing utility to graph the model over the specified domain. Bless you. When was the average score, what was the average score on the original exam? What was the average score after 4 months and 10 months? I'm going to skip letter A for just a second because that was just plugging in. T is X, and this is the common log button, just the LOG button on your calculator. Kiddos, for letter B, could you have done this on your calculator? Yes. However, could we have also done this one by hand if we're just plugging in 0?
Yeah.
What's 0 plus 1?
1.
What's any log of 1, aka base to what power is always 1? Any base
0.
to what power is always 1? 0. That just simplifies to be 0, so therefore 80 was the average test to begin with. 80 was the average test to begin with. So then what's going to happen for letter C? Let's see if we can do this one by hand. Plugging in 4. 80 minus 17 log of 1 plus 4 is... Can we solve this one by hand? No. The one thing we could think of is 10. Log is 10. 10 to what power is 5? 10 times 1/2 is 5. Go ahead. Thanks for asking. I appreciate it. Back of the room. 10 to what power is 5? Nothing. 25 to the 1/2 is 5. That does nothing. So, someone, calculator, real quick, who can help me out? 80 minus 17, common log of 5, or who already has it? Because your power workers, not your power workers, that is. What do you got, Melanie?
68.1.
What? The average score went down after 4 months? Yeah, that makes sense, right? Isn't that why we have to have, like, cram sessions for finals week? Because your brain has forgotten a lot of things that it learned earlier? Interesting. So that's natural for your brain not to hold on to things as well as when you first studied them? Which is why teachers try to think through different things, like not just helping you or trying to have you memorize for the short term, but for the long term. Ooh, talk to Mrs. Johnson. She knows tons about this stuff. I wish I knew tons. Okay, the last one. What's going to happen after 10? What do you guys expect as far as the class average on the test? Yeah, after 10 months, that's like second semester sometime, trying to remember the first test. 63? Oh, interesting. Cool. Was that as low as you guys thought?
Oh, it's 11.
62.3.
62?
My bad.
That's okay. But isn't that kind of interesting? So if the class was able to average an 80, in 4 months it would already be down to a 68, but in 10 months it only went down to a 62. Which means the brain is forgetting some things, but some things it tends to hold on to. No, an equivalent test. So it's like you trying to take a test on chapter 1 when we're in chapter 9. Which hopefully in math, that's the class. Hopefully in math it's like, well, you kind of practice some things like factoring probably all year long, but would you remember things like multiplicity or things like end behavior? I mean, maybe, I mean, those are kind of easy, but maybe not. It just depends. Algebra 2, how many of you guys remember the equation for a hyperbola? See, exactly, your brain forgets. All right, so here we go. Section 3 point. Did you guys not do conic sections last year?
Did we not do one?
Conic. Go team. Okay, sorry. When Mr. Crawford used to teach, certain things were covered, and Mr. Shea focuses on other things. So it's not a bad thing. It's just, yeah. Oh.
She said, oh.
Telling me right now. Wait, can I see how many Cheyites are in here? How many plates?
Oh, we pushed the
I did
joke.
not realize the ratio is that.
Okay.
People from J, people from Frank. That's what it is.
Two.
People from summer school who like tried to skip into class. Nice, go team. Okay. Unit circle might be hard. Okay. Actually, no, unit circle should be good. Graphing calculator. But you guys are good on that. Wow.
We did some.
You did unit circle? Supposed to. But for summer. Guys, we're distracted. Change of base formula. It's my fault. I know. I just wanted to. Here we go. You guys should have written down ln of x over ln of a, maybe, or log of x over log of a, or maybe any log base a of x over any log, oh, sorry, we already used a, didn't we? We should probably use a different base, like b. Good call. Good job, guys. That's the change of base formula. True? Yeah. Okay. So let's see what's going on in this section. Yes, remember, the entire chapter, I just want you to think of lots of little baby puzzles. You just gotta know the rules to solve them properly. Okay. Something's new, something's complicated. You have a to the power of, and you would think, ooh, well, hopefully, if you thought of the inverse property of exponential and logarithms, that you could cancel out and say just u, except there's a plus. Kiddos, off to the side, I need you to think way back. If you had x, hold on. If you had 2 to the x plus y, when do powers get added? When do exponents get added? Multiplication of like bases. Exponents get added with multiplication of powers with like bases. You guys agree?
Yeah.
Usually we're going from here to here, but we can go backwards. So what am I going to do with this problem? Split it up. And say that it's a to the power of log base a of u times a to the power of log base a of v. Which means this is the exact same thing as u times v. Do you guys agree? Inverse property. The exponentials and the logs are canceled out. U and v remain. U times v. So if this one equals that one, then we can make the following statement. You ready? We can say a to the power of log base a of u plus log base a of v is equal to u times v. Right? The first equals the last?
Yes.
Ready for your minds to be blown? How could I undo the a? No. I need a log to undo an exponential. An exponential to undo a log, but what I do to one side, I must do to the other. So what else can I say? You guys remember the product property of logarithms, that if you have a log of a product, it's the same thing as the sum of two separate logs? You just figured out why that property is what it is, but sadly, even though there are two other properties we probably should look at, I'm going to say I could do a similar process with each of them. Long story short, the reason why this property is true is because when you multiply like bases, the exponents add. When you multiply like bases, the exponents, which are the logarithms, add. So what other properties are there? Well, there's three super important ones. Now pause, look up here. Do you guys notice that these formulas are the exact same, except this one says any log, this one says ln. He's a special one, but it works for him too. This side is just saying ln's show up a lot in higher math. And so don't forget that he's a log also. so he follows the same pockets. Let's see if we can get these down. And as we get these down, the rules to the puzzles just increased. The rules that might need to be applied to the puzzles just increased. Maybe I should reword that. The challenges? The rules just got a little more involved, the puzzles just got a little more involved as well. There we go. Struggle with logarithms sometimes. Everyone's a puzzle, but sometimes, have you guys ever gotten to a puzzle where you're looking at it and you're like, I don't even know what to do?
Yeah.
Like, I don't even know what's that. Like, maybe one of those, like, well, I have some over here. Some of those ones where, like, the chains are interlinked and there's, like, a special way to pull them apart. And you're just looking at it and you're like, I don't even, like, I just don't even know what to do, right? That might be how letter A is for you. You might be like, I don't even know what to do besides plug in my calculator, which is not what they're asking me to do. There's no obvious formula to use. There's no other side. And even if there was another side, if we were to make one, the other side is an unknown. 4 to the power of what is 8? Most of us wouldn't come up with that. Because it's not an even power. It's not a whole power of 4. So what else could we do? Called
The power rule.
Yeah, but the power, you're thinking, oh. The power rule, sadly though, we need the argument to be raised to a power. 8 isn't an even power.
2 and 4.
Ah, there you go. But I can say that 8 is 2 times 4. You didn't see how I made that jump. I can think of 8 as 2 times 4. Is there any special relationship between 4 and 2 as far as powers? 4 is 2 squared. So what is 2 in relationship to 4? If 4 is 2 squared, then 2 is 4 to the half. Square root of 12. So I can rewrite this as log base 4 of 4 to the 1/2 plus log base 4 of 4. Can you guys tell what that would become? Log base 4 of 4 to the 1/2. What is this one? Just 1/2. If you want to think about it, the 1/2 could also pop down. Log base 4 of 4 is 1. What's this one going to change to? 4 to what power is 4?
1.
Some of you might have figured out that 8 is 4 to the 3/2 power, but most of us needed to kind of break it down in order to realize. Any ideas for the next one? What base is a common log? So 10, if we wanted to, 10 to what power is 9 over 300? Ooh. The exponentially thing from section. Okay, so not that. Now what? We could do that. We could do common log of 9 minus common log of 300. Does anybody see how that still doesn't match with 10s, right? Because we want it to match with 10s. Has anybody thought of reducing the fraction? 9 over 300. What does that do? better. Why do I like that a little better? Let's go to what Colby was saying. Log of 3 minus log of 100. Why am I going to write it log of 10 squared? Common log is a base of 10. So if you need to write it for yourself, you could write a little 10 down there. Kind of cheating, but log base 10 of 10 squared. The 2 could come down, if that helps. Or just say 10 to what power is 10 squared? Well, that's 2, right? What are we going to do with this guy? Ten to what power is 3? We could undo the log. We could try to undo the log. Are you thinking a change of base formula? But if we were to do change of base formula, we'd go log base 3 of 3, which could be nice, over log base 3 of 10. Oh, that's not nice either, Ryan.
If you want to solve it, can you just switch the negative 2 over to the other side?
Double checking that everyone's reading this really quickly. Ryan's thinking, can't you just move the negative 2 over to the other side? The problem is, I guess we could, but then we usually want to solve for the variable. So we probably don't want to move the 2 somewhere else, or else we might get into some trouble. Kiddos, on this one, that's technically as simplified as you could go. Anything else is going to be going down a rabbit hole. Do you guys know the reference? Alice in Wonderland. Going down a rabbit hole is like basically just going to where there's no real destination that's helpful or effective. Okay? What about if they were to give you directions to expand? They can say expand or condense. Expand means it's already been condensed. A sum has been made into a sum of 2 logs has been made into the log of 1 product. The difference of 2 logs has been made into the single log of 1 quotient. If you're expanding, it has all been condensed into a single log and you need to break it apart into its simpler pieces. There's something called logarithmic differentiation in calculus. That depends on you being able to expand logarithms. Let's practice it now. Expand just means pull apart, but using the formulas. So, pulling apart a single log with a very involved argument legally into addition and subtraction of separate logs. Using product, quotient, maybe even power formulas. Since you're honest, I'm going to give you the answer to letter A and see if you can connect the pieces or connect the dots. Sound good? What will be the in-between step? Times, right? Every time you have a product, can't you separate it with an addition of a new log? So how did I get to the final one? I said, oh hey, there's also a power. But first, I had to split apart the 5 from the x cubed because 5 was only being raised to the 1. X cubed was being raised, x was being raised to the 3rd. I was only allowed to bring down the 3 outside the log involving the x. The 5 had to just keep with the 1. Unless there were parentheses that made the 5 be cubed as well. So what do you guys think? Can you just get to the answer like that? What's the property we use on this thing? There's going to be a minus. Can anybody see the other property we use? Bless it. You would use the quotient and the power. because you could rewrite the numerator as 3x minus 5 to the, what's the square root as a power? So can you see what I'm going to write? 1/2 ln of 3x minus 5 minus. Does that make sense?
Yep.
The numerator, denominator, there's a quotient, I can split it up to be a subtraction of two separate ln's. The 1/2 can come in front of only the term that's being raised to the 1/2. Now I'm kind of skipping steps. But I'm also kind of thinking most of you are tracking. Give me a thumbs up if you're like, yeah, I see it. And some of you, just as you practice it, you'll see it better in the classroom. Kiddos, are we done? Oh. Condensing? What did we miss?
Switch it.
Pause. Maybe you guys can see why this is what you would have done. Maybe it's not too bad after all. Maybe you can finish 3.3, we'll kind of finish it on Wednesday and start 3.4. Bye guys.
So our homework is due Thursday?
Homework is due Thursday, but we're technically moving on to 3.4 halfway through Wednesday. Bye guys. See you guys, see you, come find me with questions if you have them.